Hi, Assalamualaikum and very good morning. We are in chapter 4, Design for Manufacturing, DFM, and Design for Assembly. So let's proceed with the first slide. So this chapter will address assembly primarily as it relates to the thermoplastic part designs. Virtually every finished part requires some assembly, which is mechanical fasteners, welding, bonding, snap fit joints, or other joining techniques. Optimizing part assembly should begin with the concept stage and continue through product development and production. At each stage, look for opportunities to simplify and improve the assembly. So, consideration to be taken first is consolidating parts, reducing fasteners and assembly steps, improving automation, and selecting other assembly methods. So what is actually the part consolidation? It is the joining the different parts or something together in order to create cost effectiveness. So within the constraints of good molding practice and practical mold construction, we must look for the opportunities to reduce the number of parts in an assembly through the part consolidation. Okay. Second, features to ease assembly and assure correct positioning and orientation. So in chapter 3, we have discussed so many part features. So we need to assemble each of these features in the correct position or shape or the orientation. Third one, the optimization process should address this assembly for repair and recycling. And the last one, good communication and cooperative between the various design and engineering discipline is essential. Okay, we proceed with part consolidation. Scrutinize your total design for opportunities to combine function and reduce final assembly count. Example, attaching a gear to a shaft. So it means that we need to examine in detail with careful and pay critical attention to some design which maybe we can combine the function that can lead to reduce the assembly. This figure show three example of scrutinize. Okay, first three-piece assembly with roll pin. We have three assembly. This is gear and this is pin. Okay, so we have three part, 1, 2, and 3. This is two-piece with snap-on gear. Okay, gear and the snap, and one-piece molded gear and the shaft. Okay, shaft is a long narrow part or a section forming of the handle. So we have a gear here. A variety of factors including required strength, wear properties, and moldability will determine which of these design option is most feasible, which is most suitable. Okay, proceed with the next slide. Consider design options or the alternative that eliminates or reduce the needs for hardware. So this is some of the part consideration. We have hardware, which are cable tie, full surrounded screw retainer, snap in. For the part in molded in, we have C-hole retainer, pegs and wall tab, double snap projection, slot and retainer clip, adhesive bag, pegs and floor tab, alternative. So molded in features can replace cable guide hardware. Alright, mechanical fastener. Mechanical fastener including screws, bolts, rivets, and others. So bolts and rivets means the metal pins, and their installation often represent a large portion of total assembly cost. So by considering the replacement of the mechanical fastener with snap fit joint, molded in hinge, latch, and other similar design features, we can reduce costs. Third, choose from the multitude of inexpensive off-the-shelf varieties to lower costs. For example, use of spring clip fastener. Okay, this is the example of latches and stripe. Okay, these latches can replace the use of screw and bolts. Okay, for spring clip fastener, this is some example of spring clip fasteners, and they have so many shape like straight legs, square back a leg straight, barbs on a leg, barbs on both legs, and so on. Where is the Okay, we have to standardize the fasteners to simplify inventory control and automation process, as well as reduce unit costs. So how to standardize fasteners? So we can use hex holes to captivate nuts during assembly. So it means that we use the types of hexagonal holes. And second one, select good quality screw with shaft to head diameter ratios and head style suit to automatic fit in assembly equipment. So the screw to attach with the shaft part um, must be within the diameter ratio of that part. Avoid handling loose washer by using screw with washer fixed under the head. Okay, I want to show you the example of um, the screw. Okay, this is the example of the screw with washers affixed under the head. Okay, this is because it's split. Use self-tapping screws to avoid a secondary tapping step. And the last one, use metal threaded inserts for screw connection subject to frequent disassembly. We look at the snap fit joint. So both economical and versatile, snap joint can eliminate fastening hardware as well as reduce assembly and disassembly costs in a wide range of applications. So although they vary in appearance, all snap fit joints rely upon the brief deflection of a flexible member to interlock a depression or undercut with a protrusion on a mating part. There are varieties of snap fit joint. This is the example of cantilever snap arms, and this one is a torsional or annular snap joint style. Okay. So the shape of the undercut will determine if the joint can be separated later. This is the example of the shape of the undercut. A snap fit design with an angle undercut contact can be disassembled without first deflecting the snap features to disengage the connection. If the design properly, snap fit joint can secure part of assemblies such as solenoids and switches, replacing more expensive screw. Special snap joint design can also act as a latches for access doors and panel. So before this, we use latches, which is a metal bar with a catch and lever used for fastening a door or gate. So we can replace by using the snap fit joint. Multiple snap arms or a combination of snap arms and rigid undercut can often secure covers and panels. So this is the example of latches. This is the figure for multiple snap arm, secure cover. Okay, multiple snap arm. Okay, we have 1, 2, 3, 4 to secure the cover in this assembly part. So this one is the positioning, post and snap arms. Okay, that eliminate screw and speed the process of assembly. Fit joint provide both secure attachment and easy disconnection of electrical connectors. They also facilitate quick and easy detach of electrical component for repair and recycling. So some rules of thumb for designing snap fit joint include design parts so that the pressure during snapping does not exceed the allowable strain limit of the material. Secondly, design parts so that the flexing member of the snap fit joint return to a relaxed and deflected position after assembly. Avoid sharp corner in high stress areas such as the base of a cantilever arm. Avoid excessively large radii that could lead to sink or void. And the last one, avoid thin wall section that could lead to filling problems.